This is the Pure Maths paper 1 from 2020, just regular A-level maths. Let's just do it. So binomial expansion, we get the expansion formula here. This is for whole number n's, so that's AS maths. This is the one you want for n's that aren't whole numbers, like this half isn't here. So we'll just use this formula. We'll just replace x with 8x, and every time we see an n, we'll just use a half, and I think you just get this. So replacing these x's, this x and this x squared gets replaced with 8x and 8x squared. Every time we see a half an n in here, we replace it with a half. The next one is a half times half minus 1 times half minus 2. And those are the first four terms. Put it in the calculator to get all the coefficients, and you get this. Explain how x equals 1 over 32 could you be used as an approximation. Now, root 5 is 5 to the power of half. So what we want this to become a 5, right? Except, actually, if you put in x as 1 over 32, what you actually get is 1 plus a quarter, obviously, which is 5 over 4. And when you root that, you get root 5 over 4, which is, you can root separately, root 5 over 2. So that actually works. It's not the most direct way, because the most direct way doesn't actually work because of this condition here. If you just try and make this 5, it doesn't really work so well because of this. So actually, this is the best way of doing it, their 1 over 32 thing. And all we have to do is if we put in 1 over 32, what I'm saying is we would approximate root 5 over 2. So all we have to do is double this entire series here, and we'll get the approximation for root 5. Good, so question 2 then. So take log of base 4, probably the best idea. That'll cancel out this 4 here to get 3p minus 1 over here. This can be typed into a calculator. I guess I brought the 210 down first, I guess, who cares. Then add 1 divided by 3, and we end up with the answer. Question number 3, so I just decided here, I think, that, well, a to b is just O to b minus O to a. Just to give you a very quick rundown, if that's a and that's b, I know this is 2 dimensions, but it doesn't matter. If that's a and that's b, a to b is this vector here, right? And to get from here to here, what you would do is you do this, which is minus O to a, because you're going backwards. This is O to a, so this is minus O to a, plus O to b, in other words, O to b minus O to a. So yeah, we can just do this. We'll do this one minus this one, that gives us that. I show that OABC is a trapezium. So we have A to B as this. So if that's one side of the trapezium, the other would be O to C, because that's using the 2 points that you haven't already used. So we've used A to B, and then O to C will be like 2 points over here somewhere, maybe here and here. And O to C is just this, which is just twice that. So those two vectors are parallel. So two of the sides in this four-sided shape are parallel, and that's the definition of a trapezium. So I think all we have to do is say that. Question 4 then, so you could find the inverse function of this, or you could just set f inverse of 7 to be y, and then move this f inverse over to this side to make it a regular f, in the same way that if the function was sine of y, you could move it over to be sine inverse of 7. So you can just move a function either side by doing inverse, non-inverse, and so on. Okay, so just input y into this, and we get this, and then we can just solve this for y. And the reason that solving that for y is good is because we defined that to be f inverse of 7, so therefore that will be the answer there. And the next thing, I don't think, well, there probably is a better way of doing it, but all I did was I just put f into f. So I just put the function of f, which is this thing here, into f every time I saw it, and I got this, and then there's some work to do. I'm going to obviously expand this out, but also make these two things look like this. So 7 is the same as 7x minus 2 over x minus 2, because they would cancel, just to give you 7. But now I can put these two fractions together, because same denominators, and exactly the same thing's going on down here. Of course, just be careful here, when you take away 7x, you then add 14 in here, because of minus minus. This cancels out with this, to just leave you with that over that, and you could also simplify those things, and you get down to there. Question 5 then, so first gear is this, sixth gear is this. So how many things do we have to add if this is arithmetic to get from here to here? Well, add one of the whatever the difference is between the terms, and you get to second gear. Add another thing, you get to third gear. Another thing, you get to fourth gear, and then so on. I think you have to add it 5 times to get from 1 to 6. You can count that if you want to, but essentially, as long as you think, oh, adding it once gets you to second gear, that means adding it 5 times gets you to 6, right? It's just one more than where you are. So yeah, this is good. We'll solve this for k, and then to get the third gear, we'll just take the first gear and add 2 lots of this, and we'll get that. Given this is now in geometric, that means this is basically the same, except it's 28 times k to the 5. We're applying this geometric difference 5 times. So it's 28 times k to get to second gear, times k to get to third, times k to get to fourth, and so on. You do it 5 times to get to 6. So then we solve this, we get k as this, and to get to fifth gear, we just have to apply it 1 less time than we did there. So 28k to the 4, where k is this thing here, and we'll end up with this answer here, which will be our answer. Question 6 then, so it's the R formulas first. If you're, you probably just want to go and memorize the R formulas, but if you don't, this formula helps you out in the formula book. It tells you what to do with this thing here. So what we can do is we can split it out like this, using this idea, where x is a and alpha is b, essentially, and we get this. And now just compare this with this, right? Because r and cos alpha and r and sine alpha are just constants. So for this to be equal to this, which is essentially what we want to write this in the form this, for this to be the same as this, the coefficient of sine x here, which is 1, must equal the coefficient of sine x here, which is r cos alpha, and the coefficient of cos x here, which is r sine alpha, must equal the coefficient of cos x here, which is 2. And of course, we can do this one divided by this one to get tan alpha is this, solve for alpha. And if we square both of these, we'll get this and this. And then if we add them together, we'll get this. And then if we factorize out the r squared, we'll get this. This is just 1. And we'll get r squared is 5, which means r is root 5. Again, if you just memorized how to find r and how to find alpha using tans and squares, then that's fine. But that just derives the result, I guess. The temperature is this. How could we use this model to deduce the maximum temperature? Well, this is sine of this plus 2 cos of that. And we just learned sine of something plus 2 cos of something can be written in this form with these two numbers here. And all that it is just x has become this complicated thing here. So all we have to do is we can say this thing here can be written as theta plus 5 lots of this, with r as this, alpha as this, and x as this complicated thing here. So we just end up with this. But of course, the thing that's interesting about this is that sine can take a maximum value of 1. A sine of anything, no matter how complicated it is, can take a maximum value of 1. So to maximize theta here, which is the maximum temperature, I guess, yeah. To maximize theta, we just want this to be 1, in which case the temperature is 5 plus 2.24, which is 7.24. And the time when this occurs, of course, we just need this bit, again, just to be 1. That's what I just said. We need this to be 1. So we will set that to be 1. We'll do sine inverse, which is pi over 2. And then we'll solve this. Of course, these are just numbers. They go together. You can do some stuff here, and you eventually end up with this, I believe. And yeah, we'll have our answer. Instead, no, we won't, because this is, it says find the time of day. So this is 13.23 hours after midnight. So it's definitely going to be 1 o'clock, but not 1 o'clock and 23 minutes, of course, because you need to do 0.23 times 60 to work out that it's 13.8 minutes past the 13th hour. And so therefore the time will be 13:14 rounded to the nearest minute. Of course, the clock would read 13:13 because we don't round time the moment we get past 30 seconds, but that's what they're asking you to do here because I don't know. Anyway, this question here. So firstly, let's deal with the curve, I guess. It's got a minimum point here. So you could write the curve as this, right? So this here is a quadratic that's the right way up that has a minimum point of minus 213, which is perfect. Except this quadratic here does not go through 0, 25. You can check, but f of x is not 25 when x is 0. So what we need to do is we need to put a constant in here, and we need to solve for that constant. So if we have x is at 0, f of x is 25, we'll put those in. We'll get this. 0 plus 2 is 2 squared is 4. And then we solve for a as this, and then this is the actual quadratic we're looking at. The line then, we can just do an arrow across here. That's 2 across because of this minus 2. Arrow up is 12 across. The gradient is 12 over 2, which is 6. Clearly y-intercept of 25 means this is the line. And this region here is anything lower than this line or equal to. So we're going to be lower or equal to this, and anything above the curve, so greater equal to that. We can put that together and write it a bit like this, I guess, is how we can write it. Go to question 8 then. The rate of increase of n, so that's dn by dt, right, is proportionate to n. So dn by dt is proportionate to n. You can write that using GCSE as dn by dt equals kn. Did I say that right? The rate of increase of n is dn by dt proportional to n. So it's proportional to n, which we can just write as equals kn for some constant k. We can then just do differential equation stuff, right? Divide by n times by dt, and we get this. And then integrate both sides to get log n and kt. And now this is a completely acceptable answer. It's probably not what most people thought. What most people thought probably was to do with the fact that rate of increase proportional to itself is just basically the definition of an exponential. So you can just write n is equal to, say, a e to the kt. But just to prove that this is also right, we can raise both sides to the power e, and we get this. This is a summing in a power here, so we can just write like this, right? Because you've got the same base here, so it's going to be add the powers to get this. This is just a constant, we'll call it a, and you get to the thing that a lot of people might have just thought to write down anyway. But in any case, and of course you can differentiate this even, just to check you're correct. Like differentiate this, you get this, because this just comes down, doesn't it? And therefore dn by dt is proportional to itself, n. This is just n, isn't it? So this definitely works. And so does this, but whatever. Kind of an interesting question. Differentiate this then, so product rule. So this is the first function, this is the second function. We'll differentiate the first one just to get 2x and shove that in here. Leave the other one alone. And then we'll leave all this alone and we'll differentiate this here, which just brings a -2 down, which I put there. And that should be that. We can do some simplifying though, I guess. So obviously simplify those things, you get this, then factorize out an e to the -2x. We could also factorize out an 8, which I think I only noticed here. And when we do that, we'll get the right answer. Just write it down exactly like they've got it, which usually I'm much too lazy to do, but I apparently did in that case. Hence, find the stationary points. That's f dashed is 0, isn't it, for stationary points? This can never be 0 because it's an exponential, so this is going to have to be 0 instead. I think that if we write it like this, factorizes to get x is 2 or x is -1. And then the exact coordinates then, so we need to sub x is 2 into here, and we get this. And then we need to sub x equals -1 into here, and we get that, and so the coordinates are this and that. Good. F and G are defined by this. So G is just stretch factor 2 of f of x vertically. So the range of G, well, the range of f is, well, it can go as high as it wants because this goes upwards, but it goes down to, well, this one was this one here, wasn't it? So this is the y coordinate at this point here is -4e squared. So when we stretch that out factor 2 vertically, that will go down to -8e squared. So I think the range of this is just anything above -8e squared, because again, you can go as high as you want up here, but you'll just be limited down here. Now the range of h, this is very similar, except for this condition here, which is x is bigger than or equal to 0. So we completely ignore this side of the graph. We're just looking from here up to there and down again. Now we're stretching it factor 2 vertically again, and then moving it down 3. So currently we're between this point, so let's just find this point. We'll sub in x is 0 into here, and this just goes away, and this becomes a 8, I think, or sorry, a -8. So that's currently a -8. If you stretch that out factor 2, it goes to a -16, and then move it down another 3, that takes you to -19. So we're definitely bounded by -19 below, because again, we're just ignoring this half of the graph because of this. And now upwards, we're maximum point is here, which is this y coordinate here. But again, double that and then take away 3. So double it for 16, e to the -4, then take 3 for this, and I think we're trapped between there. That should just be of course, that should just be a y, not a -y. I don't know why I've written -y there. Who cares? Question 10. So lots of the stuff to do for the substitution. Firstly, let's change the limits. So if I put x as 10 into here, u is 3 because they're positive, q is positive, and then put x as 5 into here, and we get u is 4. Sorry, u is 2. Again, positive because of this. Next, we'll just figure out what x -1 is. Well, that's just take 1 from both of these, you get u squared, so that will be replaced by u squared. What about root x -1? Well, just root both sides here, you get u. So that will be replaced with the u. And so it'll be 3 plus 2u with a u squared on the bottom. Dx then, so dx by du is 2u. Move the du over here, and we get this. That will be replaced in there. I think once I've done that, everything just ends up being exactly right. This u will cancel with one of these u's, and you'll just get what they wanted you to get here. I'm going to write this with this du down here, just because I think it's better. And now, of course, to integrate this, which is the second part of the question, this needs to be split up into partial fractions. So times this here, and just leave the 6 alone. If you set u to be 0, you get 3a equals 6, so a is 2. And then if you could set u to be something else to make this 0. Otherwise, just say, if a is 2, you're getting 4 u's from this, and there are no u's over here, so b must be -4 to cancel out those u's, and we'll end up with this. We can, of course, just integrate this immediately, and we'll end up here. This is a 2 now, because when you derive this, you get another 2 here, which will make that a 4. Sub in 3 and 2. All that there really is to do here is, I mean, there's a 2 in front of everything, right? Which I could have factorized out of the fraction in the first place, or out of the integral in the first place. But what I did was I just factorized out now. I think I'm working up here now. And now when you take away logs, you divide, and when you add them, you times. So this is going to be 3 times 7 is 21, divided by 2, divided by 9, to make 21 over 18. And now this 2 can move up to here to square both of these. You can simplify that, I guess, as well first, and then you make this here, which I think is good enough. But if you want to be super clear, a has to be 7 squared over 6 squared, which is 49 over 36. 11 then. So we've got this circle, we've got this circle. Show this angle here, which is A or B. So this is this angle here. Show that angle. Now this circle has radius 10, so that's 10, that's 10. So I thought, why don't I just work out this distance by working out these intersections between these two circles? I could then work out this distance, and then I could do some cosine rule backwards to find this angle. So that was my plan. So let's find the intersection between this and this. Rearrange them both for y squared, and then set them equal to each other. And now something really interesting happens here, which is after you expand out, the minus x squareds cancel, and you just get one x value, which is this, which actually isn't surprising because both intersections happen at the same x value. But what's better is that that x value is at 9.5, which means this distance here is 9.5, which is great because then I just abandoned my plan and I said, well, if I know that's 9.5, this is a right angle triangle. I can just do, adjacent and hypotenuse. Cos inverse of 9.5 over 10 gets me this angle, just regular SOHCAHTOA things. And then I'll do that and I'll double it and I'll find this whole angle. And if I double that, I get this thing here. Now it wants me to work out the perimeter of the entire thing. What I decided to do was I could work out the missing arc length of this circle very easily because arc length in radians is just r theta. And I know this theta here that would make this sector here. So I just need to do that theta I just found times r, and I'll find this missing arc length. If I do exactly the same for this circle and find this missing arc length, I could then just do the full circumference of both circles added together minus those two arc lengths, and I'll end up with the perimeter of the shape. So that was my plan. I first worked out that this here was 5.5 because its center is at 15 across. This plus this is 15. So I did exactly the same thing I did before with the previous question. This radius is root 40, so now I can just do cos inverse of this over this to find this angle, and then double it, and I'll find the entire angle that would make the sector that I'm talking about here. And now I can just do r theta to find this arc length using this theta here, which is the angle that's double through here. So just times that by that. I did it over here first, actually, so I used the arc length the angle we found for AOB first, times it by 10, which is the radius of this circle here, to find this missing arc length. And then I'll do it on this side as well, and I'll find this missing arc length. And now I can just do the circumference of the circle plus the circumference of the circle minus this arc length minus this arc length. And I think I'll have the perimeter, which is what I'm doing here with the radius is there, 2 pi r, of course, and we'll end up with the answer. 12 then, so cosec is 1 over sine. That seems like the obvious thing to do first. You can write this as sine squared over sine. You can put these fractions together. 1 minus sine squared is cos squared. I guess you can write like that. And then this is cot and this is cos, which is what they wanted you to get. So that's very nice and straightforward. Hence or otherwise solve this. So replace this with what you just found, which is the same just with x's here. Now you can divide both sides by cos here. But if you do that, you have to recognize that if cos of x is 0, then that will be a solution. And it is. Cos of x is 0 happens when x is 90, which I'm working in degrees here. Yeah, sorry. So that's good. That's one solution found already. Now here, clearly, x could be 3x minus 50. Add 50 to both sides, take away x from both sides, you get x is 25. And that's one legit solution. And always check the solutions by typing in calculators, because why not? But also, you could, tan is repetitive every 180. So is cot. So x could equal 3x minus 50 plus 180. And you can sort this out, but this will make a plus 130, and then that will be a minus 130 over there. And this will give you a negative solution, which you don't want. So actually, we don't want to be taking away 180. I think we don't want to be adding in 180. We want to be taking it away because it's symmetrical in both directions, right? And by taking it away, I can find more solutions that are actually in the right direction. And I think if you check another one, if you take away another 180, you'll end up with an x bigger than 180 here. You can check that for yourself if you want to, but this solution, and this solution are the only ones that exist. Question 13 then, so given it's periodic order 3, now what that means is it repeats every 3. For example, this one here, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's periodic every 3. It repeats itself every 3 goes. Now A1 is 2, so therefore we can check what A2 is. So if we put n as 1 in here, we'll get this. A1 is 2, like I said, so we'll put that in, and we'll end up with a very simple this. We can then find A3 by putting A2 is 2k in here. The k's cancel, and you end up with this, and the 2's cancel as well. And then when you're finding A4, the key thing about A4, you can use A3 obviously, but the key thing about the fourth one is it's the same as the first one, which was 2. So this is 2, and this is what we found before, the A3, and this just, if you cross multiply and expand and rearrange, you'll end up with what they wanted you to get. For this sequence, explain why k isn't 1. Now, if k was 1, the first term would be 2, the second term would be 2, the third term would be 2, and the fourth term would be 2, which technically is periodic every 3 because every third number is the same. However, it's just periodic 1, and that would be defined as periodic 1. But technically, to the maths that we did, that would work as periodic 3 as well, but it's actually period 1. Find the value of this. So we're just adding up all the terms from 1 to 80. So it's going to be 2 first. Then if k is, well, we actually have to figure out what the other k value is. So factorize that. K is 1 isn't the answer. K is minus 2 is. So if we put in minus 2, we get the first term 2, second term minus 4, third term minus 1, and fourth term 2, and then so on. So in groups of 3, these things add up to 2 minus 4 is minus 2, minus 1 is minus 3. So we have groups of 3 adding up to minus 3, I think. And how many of them do we have? Well, 81 is a multiple of 3. And it's, I think, what, 27 times 3? So I think we have 26 lots of this minus 3. And then 2 terms left over. 26 lots of 3 is 78. So I think we have 2 terms left over, which will be these last 2 here. So these 2 add up to make, well, we could just put them straight on the end of this, and we'll end up with our answer here. I think would be another way of doing it. 4 then, so time t, radius this, volume this. So volume of a sphere is this. That's, I think, in the formula book. I think it is. Volume is model is decreasing at constant rate, so dv by dt is just minus a constant number, which we'll call positive to make this negative. So therefore it's decreasing. We can also say that dv by dr, differentiating this, is this. And what I can do now is I'm looking for dr by dt, but I have these 2 things. So I think dr by dt is dv by dt times dr by dt. That should be a, what should that be, a t? I think that should be a t. Apologies, let me fix that. That should be a t. No, it shouldn't. What am I doing? That should be an r, and that there should be a t. That works now, right? dr, no it doesn't. That should be an r, and that should be a v. Which is that what I had before? Am I just an absolute muppet? That's correct now. This cancels out, you get dr by dt. Of course, this I have because it's just this, and this is just this upside down. So we get that, and then, yeah, this is just all a constant with r squared on the bottom. I didn't really know how to write that, but yeah, that's what I did. I think it's there. When t is 0, r is 40. When t is 5, r is 20. We can shove those results into here, I guess. Well, actually, no, first we need to solve this, don't we? So times by times by dt, times by times by r squared. This is incredibly easy to solve. It's just this when you integrate both sides. Don't forget the plus c. I have a great friend who sung a fantastic version of a song that did just that. It was amazing. Anyway, t is 0, r is 40, put those in. And I think we just immediately get this, yeah, because this just goes away. T is 5, so we refine it down to this. And then to find k, we just use this one here. So t is 5 when r is 20, and we'll find k is this. And then, yeah, we can just write this out with those constants in it. Good, we're done. Find a limitation for which this is valid. So a couple of limitations here. Firstly, t has to be positive, because otherwise time doesn't really work. And also, if t gets too far, you're eventually going to end up with a negative r value. Like, this model has to stop when r is 0, when the balloon's empty, which we'll say is r is 0. So let's set r as 0 into here, and we'll solve for t, and we'll get this is t. And so this model works for positive times and up to here when the sphere completely deflates. So yeah, these 2 conditions, which I guess I could have written as 1, but who cares? Question 15 then, show this thing here. So to do this, we're going to need some implicit differentiation with some product rule as well. So differentiate this first here, it just becomes 2x, leave this one alone. And then leave this one alone, differentiate this for sec squared y, but tag on a dy by dx because you differentiated. That should be a y, apologies. How many times have I messed that up? If I mess that up every single time, oh my gosh. And I can't even be bothered to fix this because I think that's probably fixed it. Good. So that should be a sec squared y, and then you just tag on a dy by dx because you differentiated the wrong thing. You've left this one alone, as product rule says. That equals 0 because differential of 9 is 0. You can then, of course, just rearrange this slowly and you get this. Now, a few things to do here. Firstly, tan y, you can just write as 9 over x squared because you're trying to write dy by dx with no y's in it. So we can get rid of this y by doing that. Now, this one here, everyone knows this thing here. If we divide both everything here by cos squared, we'll get tan squared plus 1 equals sec squared. And so we can replace this with the tan squared plus 1. But of course, tan squared of y is just, or to square this, it's 81 over x to the 4. So we can replace that in there. And from here, we've just got some work to do to make it look like this. This is just some like annoying algebra, essentially, to try and put these things together. And we get here, this thing goes there, and this thing goes to the top. So it ends up being like this, and then these cancel out. And you eventually end up with the thing they wanted you to get. For B then, prove this is inflection. Now, inflection happens when d2y by dx squared changes sign. So first, let's work out that. Now, you probably could use quotient rule here, but I don't know what quotient rule is. So I'll just use product rule, putting this as a power minus 1. So let's do some product rule here. Differentiate x, you just get 1, you leave this alone, and then differentiate this here, leave this alone. This minus 1 comes down to the front, goes there. Differential of this is 4x cubed, and then this goes to a minus 2. And now this simplifies a little bit to this. Now they've told me that this is a point to look out for. So what I'm going to do is just shove this point into here, and it will be 0, which is the first thing I need. But I also need it to be a change of sign. So I need for any value less than this, for it to be something else that's not 0, and then for more than this to be either the other one. So I just picked this value, and I put this value into this, which wasn't that painful, and I got this number, which is less than 0. And then I went the other side of this, which is just by adding 0.01, put it into this, and I got this value, which is greater than 0, and therefore this is a point of inflection because d2y by dx squared changes sign. It used to be negative, then it was 0, then it was positive. So therefore it's a point of inflection by definition. And yeah, just say that. 16 then is the last question. It's about proof. So firstly, we have to set up the contradiction. So we'll assume that there are positive integers p and q that exist such that that works. We can factorize this to make that. And now if p and q are positive integers, then both 2p plus q and 2p minus q are also integers. Furthermore, this one is larger than this one, I think is what I said next. I said that this one is positive. Oh yeah, this one is positive because you're adding 2 positive integers and times by 2, which makes this one positive because if this is positive, you can't times it by a negative to get 25. So both must be positive, and also this one must be bigger than this one because q is positive, and here you're adding it in and here you're taking it away. So with all of that done, I think I'm pretty much done here because the only way to make 25 and I'm multiplying integers is 5 times 5 or 1 in 25. I put 25 first because I've said this one's the bigger one, except I've also said that this one is strictly bigger than this. So 5 times 5 isn't not an option. So the only option is 25 and 1. So let's set this equal to 25 and this equal to 1. If we add these two things together, we'll get 4p is 26, which leads to p is 6.5, which isn't an integer, and that's the only possible way that this could have ever worked, and it doesn't. So therefore, by contradiction, this does not work. Thank you for watching, and I'll see you next time.